Hey guys, it's Miss Gill. Today we are working on lesson 2 in module 11, prove the converse of the Pythagorean theorem. So our I can statement is I can prove the converse of the Pythagorean theorem and use it to determine if a triangle is a right triangle. And I can determine whether the three side lengths form a Pythagorean triple. This covers our standard G.2.6. If you would like to at this time, you can pause the video. You can go to your assignments under Focus or the File tab if it's currently working on Teams to print the blank book pages if you would like to use them to follow along. If not, you will see that the completed pages have already been uploaded for you to view for reference if you need them. So we're not going to do the Spark Your Learning right now. We're going to go straight to the Build Understanding. So if you did print the pages, we are on page 374. So it says, consider this statement: if I am in this class, then I am in the 8th grade. The converse of this statement is, if I am in the 8th grade, then I am in this class. The converse of a theorem reverses the hypothesis and the conclusion. The Pythagorean theorem states, if a triangle is a right triangle, then the sum of the squares of the shorter sides is equal to the square of the longest side. The converse of that statement is, if the sum of the squares of the two shorter sides of a triangle is equal to the square of the longest side, then the triangle is a right triangle. So it says, show that given a triangle ABC with side lengths A, B, and C, if A squared plus B squared equals C squared, then the triangle is a right triangle with a right angle at C. Let triangle DEF be a triangle such that EF equals A, DF equals B, and DE equals X. And they're talking about the side lengths right here. And F is a right angle. We need to show that triangles ABC and DEF are congruent. Remember, this means that they are the same. So they have the same side lengths and they have the same angle measurements. So can we apply the Pythagorean theorem to triangle DEF? Why or why not? If so, what can we conclude? So yes, we can apply the theorem to triangle DEF. So next question is, why or why not? Because it is a right triangle. If so, what can we conclude? So we can conclude that A squared plus B squared is equal to X squared. So what we're saying is the two shorter sides, the squares of these two legs, is equal to the square of the hypotenuse. So how can we relate X to C? So how can we relate these two together? So since A squared plus B squared equals C squared, and now we know that A squared plus B squared equals X squared, then we can simply say that X squared is equal to C squared, because these two are the same. So if this equals this and this equals that, basically we can say that these two equal each other. Or you could say X is equal to C. If we took the square root of both of those, then we would say X is equal to C. We just need to specify that where X and C are both positive because they represent lengths. So they are both positive because they represent lengths. So you can't have a negative side length. That's all that's saying. So what can you conclude about the measure of angle C? So what can we conclude about the measure of angle C? Explain and include the classification for triangle ABC. So what we can conclude is since three side lengths determine a unique triangle, the triangles are congruent. I'm going to use the symbol of triangles. The triangles are congruent. And their corresponding angles are congruent. So what we're saying is the triangles are congruent because their side lengths are the same and their angles are the same. The angle C is also a right angle. And triangle ABC is a right triangle. So guys, this is just more of that proving why we're able to use Pythagorean theorem, how we can relate triangles to one another. This isn't actually doing the converse. This is just explaining how we're able to use it. All right. So we're going to move on to the Step It Out question 2, and you can find that on page 375. All right, so it says, given each set of side lengths, determine whether each triangle is a right triangle. So in here they tell us side A, side B, side C. If they just give you three measurements and they don't tell you which one is A, which one is B, which one is C, the hypotenuse is always your longer side. So the bigger number is always your hypotenuse. All right, so we're just going to substitute these values in. So for A squared, we're going to put in 4. For B squared, we're going to put in 6. And for C squared, we're going to put in 8. And then we're going to square them. 4 squared, 4 times 4 is 16. 6 squared, which is 6 times 6 is 36. And 8 squared gives us 64. So then if we add these two together, so you can take your calculator, add 16 plus 36, we get 52. Well, 52 does not equal 64. So therefore, this is not a true statement. So it says circle the correct answers to complete the sentence. The square of A plus the square of B does not equal the square of C. So the triangle is not a right triangle. So if the two sides do not equal, then it is a triangle. It's just not a right triangle. All right, let's look at another example. So side A measures 5 inches, side B measures 12 inches, and side C measures 13 inches. So we know this is our hypotenuse because that's the bigger number. We're just going to substitute the values in. So I have 5 for A, 12 for B, and 13 for C. And then we're just simply going to square them. So 5 squared is 25. 12 squared, 12 times 12 is 144. 13 squared, 13 times 13 is 169. So now we need to see if these two sides match. That's why there's this little question mark there. So if we take our calculator and we put in 25 plus 144, we get 169. So we know that 169 does equal 169. So this is a true statement. So then we can say the square of A plus the square of B does equal the square of C. So the triangle is a right triangle. We also would call this a Pythagorean triple. So this would also be a Pythagorean triple because they're all integers, they're whole numbers, and they make a right triangle. All right, let's move on and try another one. This one, all our measurements are the same. So do you think that this one would work out? Well, let's find out. So if we plug in 9 for A, 9 for B, and 9 for C, and we square 9, 9 times 9 is 81. So we get 81 in all of these boxes. So I know there's no way I can add these two together to get what one of them is equal to. So if we did add them together, we would get 162 equals 81, and that is not true. So therefore, this is not a right triangle. So circle the correct answers to complete the sentence. The square of A plus the square of B does not equal the square of C, so the triangle is not a right triangle. All right, so moving on. Now they're asking us a few more questions, but we're still doing the same thing. They just don't have the little boxes for us to fill in. So they give us our measurements. We have 5 inches, 16 inches, and 20 inches. Are the side length integers? So the definition of an integer is a positive or negative whole number. Well, since we're dealing with measurements, they would always be positive. Since these are whole numbers, then yes, they are integers. Does a squared plus b squared equal c squared? Well, I don't know. I need to find that out. So I'm going to work the problem out and see. So this is just like on the previous page, but they had the boxes for us to fill out. So I've got 5 squared plus 16 squared, and I'm going to see, does this equal 20 squared? So now I just need to work it out. 5 squared is 25. 16 squared is 256, and 20 squared is 400. So if we add 25 and 256 together, we get 281. So we know that is not the same number as 400. So since these two sides do not equal, then this is not true. So if this is not true, then it's not a right triangle. This has to be true in order for the triangle to be classified as a right triangle. So this is not a right triangle. And this is not a Pythagorean triple. So in order for it to even be considered as a Pythagorean triple, this would have to be true. Then we would go back and look at, are they whole numbers? All right, so let's look at another question. Side A measures the square root of 3 inches, B is the square root of 4 inches, and C is the square root of 7 integers. So are the side lengths integers? We would say no. Because they are not whole numbers, they have that radical symbol with them. So don't let this scare you. Think about it as if you had any number that was the square root of that number and you squared it, it simply equals that number. All right, so it's the square root of any number squared is simply that number. So let's see what happens when we work this out. So we have a squared plus b squared equals c squared, and now we're going to plug in our values. So we have square root of 3 squared, square root of 4 squared, and we're trying to figure out, does that equal the square root of 7 squared? So the square root of 3 squared is simply 3. Square root of 4 squared is 4. and the square root of 7 squared is 7. So then we add these two together, we get 3 plus 4. We know that 3 plus 4 is 7, so 7 equals 7, so it does work. So yes. Is the triangle a right triangle? Well, if this works out, then it must be a right triangle. Is this a Pythagorean triple? So even though this works out and it is a right triangle, we go back to these numbers here. These are not whole numbers. So since they are not whole numbers, they are not integers. Therefore, it is not a Pythagorean triple. Only numbers that are whole numbers that work out in the Pythagorean theorem would be a triple. All right, so I want you to I'm going to slide it up to the check understanding. I want you to pause the video and give the questions, the two questions, a try before starting the video again. So at this time, you should pause your video and try the problems on your own. All right, so hopefully you gave them a try. Now we're going to answer these questions. Are the side lengths integers? So we look back, they are positive whole numbers, so yes, they are integers. Does a squared plus b squared equal c squared? Let's find out. So let's plug it in. So a is 7, b is 24, and c is 25. So now we just need to square them. So 7 times 7 is 49. 24 times 24 is 576. And 25 times 25 is 625. So then if we add these two together, we get 625. So this is a true statement, so this would be yes. So is it a right triangle? Well, as long as it works out in Pythagorean theorem, then it is definitely a right triangle. Then our next question is the triple a Pythagorean triple? So these are all whole numbers. They fall into the integer category. So yes, it is a Pythagorean triple. All right, so if you got that one right, good job. This one, a little more challenging, but not too bad, just because we have the two radicals in there. So are the side lengths integers? So our answer to this would be no, because we have the square root of 3 and the square root of 7. 2 is the only integer there. Does a squared plus b squared equal c squared? So let's find out. I'm going to write it up here. All right, so a is the square root of 3. We're going to square that. B is 2. And c is the square root of 7. And we're going to square it. So square root of 3 squared would be simply 3. 2 squared is 2 times 2, which is 4. I forgot my little question marks. And the square root of 7 squared would be 7. So then if we add 3 and 4, we get 7. 7 equals 7, so this would be a yes. Is it a right triangle? Well, as long as it follows this rule, it is a right triangle. Is it a Pythagorean triple? So it's only a Pythagorean triple if we answered yes to this question here. Since we said no, the side lengths are not integers, then no, it is not a triple. All right, so guys, if you have any questions, please join in for the live meeting or simply reach out to me and ask for help. I hope this video has helped you complete your Into Math assignment.